Hey, it's Caleb. If you like this video, be sure to subscribe. Hey, what's up, dudes? In this video, we're going to be talking about foreign keys. So, this is a big subject, and there's a lot of important things. So, I'm going to be separating a lot of these concepts up into separate videos. So, the next 2 or 3 videos, this video and 2 others, I think, will be over foreign keys. And a lot of things that have to do with foreign keys. What is... sorry. Anyways, this video will be talking about an introduction to foreign keys and what exactly they do. Alright, so a foreign key is a reference. And what does it reference? It references a primary key. So that's the most basic definition of a foreign key. Now, this can be a primary key in the same table or a primary key in a separate table. So let's kind of see how this would play out if we do some drawing, right? Let's think of a class for a college database. So this database has all the information for a specific college or multiple colleges, and one table is for classes. We also have a table for instructors and for users and anything else that's an obvious entity. So let's look at the class table. So we have a class table. We'll just draw it out here. Within here, we could have a class ID, which, like I said, we're just going to be using surrogate keys for most of this. You can do the same thing with natural keys, and if you have no idea what I'm talking about, just pretend I never said anything. So yeah, we have a class ID. That's an example of a surrogate primary key. We could also have an instructor. You see? So we can have an instructor ID, right? And we could have, let's say, a room number. Because we could have a table for every single room, which talks about more information about the room. Or I don't know if that's a really good example. Or we could say we have a bigger building or a bigger college, and we have a table for each building. So that's probably a better example. So we could say building ID to say which building it is in. All right, so here are 3 IDs, so you can assume that they're all keys, because almost all IDs are going to be keys of some sort. Which one is the primary key? Well, this one right here, the class ID. This is the primary key because it's the class table. Every single row within this table is going to have a class ID, whether it be 1, 2, 3, 4, 7, 12, 843, 64, whatever it is. It's going to have a class ID, every single row. So every single class is going to have its own ID. But we also have an instructor ID, and we also have a building ID. Well, since these are kind of unrelated to the class, you can assume that they're foreign keys in this example, because we're not going to have an instructor ID for a class necessarily by itself. This is going to be an instructor ID for an instructor. So that means we have another table for instructor. So this is our instructors table. I think I'm spelling instructor right. And we have an instructor in here. Instructor ID. Well, you can tell that these are a reference here. We can also have a building ID. So this references another table. And that would be the building. And then we have a building ID. Let me see if I can get this. Sorry, I'm taking forever to write and I can't even write nice. But that says building ID right there. And this references that there. So you can see there's a connection between these tables. Now we'll get more into drawing relationships better, rather than just using lines. We'll talk about more of that in the future. But as for now, we can see that these reference these columns. So the columns point to each other, and also each individual row is going to point to each other. So let me explain that a little bit more. When we have a row within our class table, let's draw this table out a little bit better so we can kind of see how it would work. So let's say this is an actual example of the values within this table. We have a class ID, and instructor, I'm just going to put I and then the building ID, just for simplicity. Okay. Dun, 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 dun. Just because I don't feel like writing all that out. So we could have a class ID, and just to make things more, just to be more accurate to what a normal database would be, we could say like the name of the class, like biology or whatever. So we could have a class ID, we could have 7 for a value. We could have the instructor ID could be 63. We could have the building ID of 16, and then the name could be biology. Well, every single column is going to have column rules or requirements. For example, these two columns here, individually, this one is going to have a rule that says every single value within this column, so as we go to the next row, the next value, every single one is going to have to reference something from the instructor table because it's an instructor ID. So that's one of the column rules. Now, same for the building ID, we could say that every single row has to reference a value within the building ID. Alright, so that means the row right here, let's say this row individually, this one right here, the class ID with 7, biology, references the instructor with the ID of 63 and the building with the ID of 16. So you can see that the column has rules set to say that every single value within this column, every single row, is going to have to reference an instructor and a building. Now each individual row, we could say, oh, this specific row references the building and 16 and the instructor 63. You see? So that's kind of how foreign keys work. Let me clear this out, kind of draw it out a different way. Let's take a look at the building table. Okay, so let's just draw a little square just to represent it. And let's say within this table, we're not going to structure the columns or anything. We're just going to say we have the building 7, 16, and 14. So these are 3 separate buildings, and we could have names for the buildings and all kinds of other things. Now, we have within the class, let's say this is the class table, right? And we have the class ID, so the class ID would be like 64, 38, 123. It doesn't really matter what number they are, and 8, right? And now we're going to have a reference to the building ID. So let's say we have 7, 7, 7, 14, right? So here's just an example. So over here we got the class ID. We got the building ID. And then we got the building ID. And then we can have more information about the building here if we wanted. Well, you can see that there's a connection between every single value, every single row within this class table has a connection with a building ID. So the entire column, building ID, has the rules that every single value within that column has to point to a value within the building ID of the building table. Now each individual row has a value that points to a specific row within the building ID. As you can see, these are all individual rows. Sorry, it's getting a little crowded here. We can see that 3 of these classes in this class table reference one building, and that's the building with the ID 7, and that could be the room legit building 74, or whatever you want to call your building. It doesn't really matter. So that's an example of a relationship using foreign keys. Foreign keys are what keep things connected. So let's say the name of building 7 was legit, because I really don't know what else to name it. Well, now we have the value legit as its name, and we connect with the ID. So rather than putting legit, legit, legit and having repeating data, that could be easily messed up. For example, if legit was changed to legit with 2 T's, or just change the name completely, well now with this foreign key, it's connected so it updates automatically. So yeah, that's kind of how foreign keys work. Just keep in mind that every table has one primary key. Now that primary key can be a combination of multiple columns if you want, but it only is defined as one primary key. For example, we could have the combination of first name plus last name. This group could be the primary key, but we're not going to have the first name primary key, and we're not going to have also the last name primary key, because that's two primary keys and we can't do that. We can have the combination of the two. But with foreign keys, you can have multiple columns having foreign key relations to different tables. But keep in mind, each column can only have one reference. So in the class example, we had a teacher ID. Well, that teacher ID, here's the class table. And let's say the teacher ID is 7, 6, and 5. Well, this can be a reference, and we could also have another foreign key. We could have the building ID, which could be 6, 12, and 8. So although we are only allowed to have one primary key in a table, we could have multiple foreign keys referencing different tables. If we wanted it to be where the instructor, I think it's supposed to be an I, so the instructor, to where the class can have multiple instructors, well, that's a many-to-many relationship, and we're going to have to redesign our tables with an intermediary table. So hopefully that's kind of making sense. I just want you to realize that the primary keys are what sort each individual tables, the foreign keys are what connect tables, and that you protect that integrity with foreign key constraints, which we'll be talking about in the upcoming next few videos. So that's all I really got to say about foreign keys in this video. If you're new to this, it might be a lot of complex thought, but don't let it overwhelm you. Just take it easy. And if you ever need, check out my I have another database design series which kind of takes things a little easier. So if that would be beneficial for you, check that out. If you have any questions, leave me a comment and I'll be sure to get to them. Thank you and subscribe.